4, 3, 2.
Okay, we are about to start a 24-hour simulated space shuttle mission. We're using our own permanent space shuttle simulator facility. I'm sitting in the mission control area of that facility. And at 8 o'clock in the morning, 6 young men who are students at the school, portraying astronauts, will board our space shuttle simulator. The hatch will be closed, and they will spend 24 hours on a simulated space shuttle mission. The mission will include scientific experiments. It'll include many of the activities you traditionally expect to happen with astronauts in space. They'll be doing some physiological checks, some experiments in sleep deprivation, a whole variety of activities that you would expect on a space shuttle mission. We've put a lot of work into making this a realistic simulation. The space shuttle itself, the permanent facility, is the size, the dimensions of the space shuttle. The equipment is designed to be as accurate a representation of the equipment they actually use on the shuttle as is possible. And we've done everything we can to make it look as real as possible. The astronauts look out the front windows of the space shuttle. They're actually looking at a 55-inch television monitor, so we can simulate views of the Earth from space. We use sound effects. We use computer-generated video. We use computer screens. We do a lot of things to simulate the environment of the space shuttle. The only thing we really cannot simulate is weightlessness. And NASA has been very cooperative in this particular mission, not only in the development of this space shuttle simulator facility, but in this particular mission. They provide us with a lot of expertise, help, advice, written materials that help us get a true feel for the nature of the space shuttle. We've gotten all kinds of publications and materials. Some of it is material that's actually used by astronauts. They've provided us plenty of advice.
I am in charge of the red team, which is one of the 8-hour shifts. I am flight commander, which means I am in charge of the personnel and shuttle, and that also means that I'm a pilot. So I fly the shuttle during my shift when we are in orbit. We'll be doing science experiments, so we'll be getting that aspect and just the practical knowledge of just the activities of the Space Administration.
Well, I'm in charge of practice landing of the shuttle. All the science experiments that go on while he's off duty, and monitoring communications.
Us astronauts will be involved in different experiments, and there's one experiment we are going to try to attempt to build a structure out of Legos according to the direction of mission control. And they will have built a structure, and by the CB radio that we talk with, they will direct us how to build this structure that they have made. We also are going to be teaching a class from the simulator to a primary school class. Right now it looks as though it will be a kindergarten class.
Just like the other payload specialists, I'm really here to do some scientific experiments, except with us, I'm teaching a couple higher grades rather than the grades that they're teaching, just because of the grade that I'm placing at the school.
Okay, how do you have to teach the kids?
Oh, it's the same thing, either by over computer, if it's linked to a network, or over the camera, whichever we decide on.
What are the few things you're going to be teaching the kids?
Just like, we have to decide that on board the ship or tonight when we're at home. So it's going to be something having to do with computers or space, or maybe a mix of both, probably.
Falling down to 75%. Over.
Did you confirm solid rocket booster separation?
Confirm solid rocket booster separation. Over.
24 hours later, they will return to Earth in a simulated fashion. They'll disembark the space shuttle, and then we'll report to an all-school assembly to be debriefed, if you will. The reason the shuttle simulator facility, the whole space science facility, was built was because of the concern on my part and several other faculty members here at University School that kids were just not as involved or interested in science and mathematics as they should be or as they may have been in the past. And we needed to find some ways to get interest in science, and in particular space science. It's an up-and-coming thing in science education. We wanted to find a way to really captivate some interest, get kids to get involved in some areas of science that maybe they might not have done before. And we made an initial proposal to develop this facility and got it approved and got it constructed. It's our hope that we're going to interest kids in math and science to a greater degree than we ever have before. This is a permanent facility. It's a remodeling job within the school to create the facility. It would be almost impossible to dismantle. Not only is the facility itself permanent, it's actually the interior of a shuttle, but the electronics and all of the simulation equipment is very complex. It would be very difficult to take down and put back up again. It remains up all the time. It's used as part of our science curriculum areas in the regular school year. This mission is, in fact, a part of that. And we also run a summer program using the facility. Well, the only thing I might add is that the astronauts and all of the kids who were working on this mission, well over 60 kids, were chosen by application. They had to convince us that they were worthy of the position. They had to develop a job application for the jobs they have. A lot of kids have put a lot of time and investment into being a part of this project. I would like you to join me in welcoming back our 6 astronauts.